Okay, we're going to do binary compounds, but first I just want to briefly return to our polyatomic ions. So we learned to name the carbonate, sulfate, chlorate, sulfate. The reason why I didn't hit this too hard in the other video is because we've already talked about what to do with the metals, with our cations, when we put them together with an anion. If they have fixed charges, so if they are known oxidation states, then it's the same thing. They get to stay just silver, sodium, aluminum. If they have multiple oxidation states, then we need to define what the charge is in the name. So tin 2, copper 2, but the name of the polyatomic that we defined in the last video stays the same. So this is the exact same naming system as with the other ionic compounds. It's just now including or incorporating in our polyatomic ions. Now's for the fun. More fun. Incredibly fun. I'm so excited. You should be too. We have this long list of how to count in chemistry. Some of these should look familiar. Mono, di, tri. Those are pretty comfortable to a lot of people. 1, 2, 3. Deca, if you're comfortable with the metric system, that should also be comfortable. Octa, octagon. So this is another one that most of us probably know. Pentagon. So, hey, look, half the list is done. Hexa and hepta, depending on how much math you've done or geometry. Nona is probably one that we don't use too often in geometry, so it's not going to be quite so familiar. And tetra also, if you do it, if you do a lot of math, then this would be comfortable too. If not, you have what, 1, 2, 3, 4 that you would have to work on committing to memory. But the way it works is this: the first element gets its full name. Just like the anion, we replace the ending of the second element with the word, or with a IDE, ide. Then you add the prefixes. So mono, though, doesn't go to anything that is in the beginning, so it's just assumed to be there. Let's do this, CO2. So the first one is just carbon. And again, no mono. The O2, there's 2 of them, so di. And then ox, and add the ide, oxide. And perhaps if you're trying to remember how to do it and you find yourself a little bit stuck, go to something that you've heard before. Carbon dioxide, most of us have heard it. You get a, it's in the news all over the place. Carbon monoxide, CO, that's another one that you've heard. Carbon, again, just the full name, carbon monoxide. And that's it. We can get all sorts of crazy. Notice that magically appeared. N2O5. So now we have 2 nitrogens, so di nitrogen. Nitrogen. Whoops, not nitrogen. Nitrogen. And then the 5, penta, pentaoxide. I chose this one on purpose. Pentaoxide. One of the things that you will see commonly done is this A taken out. Are there points deducted if you forget to remove the A? Not at this point, or probably not at any point. So you would rewrite that as pentoxide. I've actually seen it done both ways. So personal preference, it's kind of like N or A when you use those different versions in front of something coming with a vowel on the other side. You can leave out the A if you have this kind of clumsiness that happens between the prefix and the element name. So let's do one more crazy. I'm going to write it out. P4O10. So tetra for 4. Tetra, phosphorus, phosphorus. So see, it's just its full name. And deca, oxide. That's it. So that might look daunting, but really that's all the rules are telling you to do. So now you have named, gosh, what have we named? Polyatomic ions, ions. You've named ionic compounds, polyatomic compounds, and now just binary compounds. It's getting exciting. Let's go ahead and do one more thing. I'm going to bring up this sheet. We're going to name acids. So I mentioned in the other video, and then I stopped myself, and now you're going to see why, that hydrogen is what we define as an acid. So when we combine it, we end up with acidic compounds. Some of the examples are here. We have our nitrite and our sulfite and our chlorite, hypochlorite. So these ions combining with our hydrogen form acids. Now the way we name these guys, I like these mnemonics. Last night I saw a mouse. So if it ends in an ite, I replace it with OUS. So take the hydrogen out and cross out the ite, replace it with OUS. Nitrous acid, sulfurous acid, hypochlorous acid. Ite with aus. And the other one is I ate a bug, it. Huh, that shouldn't be too hard to remember. So if it's 8, cross out the hydrogen, and we replace the 8 with IC, ick. Just remember the K doesn't go there. So hydrogen carbonate would become carbonic acid. Hydrogen phosphate would become phosphoric acid, and so on. There you go. You have now named everything there is to name. Hold on. Yep, I'm going to stop there, and we will talk about acids and solutions versus binary compounds in the next video, because we are going to start writing chemical equations and reactions. It's so exciting.